One of the most common things you'll be asked as well about surds is to rationalize the denominator, which is a way of saying that if the denominator is not a rational number, you want to rationalize it. So you want to change it to a rational number. And you can do this by multiplying the denominator by the same number. So let's see, if you have 6 over the square root of 3, well, now I don't have a rational number in the denominator, but I want to make it rational, which is hence the title. And what you do in this case is you actually multiply it by, you multiply the numerator and denominator by the same surd. The idea here is that they will cancel out, so we'll be using property 1. It's the same idea as when you want to change the denominators to make them the same, for example. So you're going to multiply the numerator by square root of 3 and denominator by square root of 3. We do this because we don't want to change the value of this fraction. It's still going to be equal. We're just changing how it looks like, but it's still the same value. So in this case, the square root of 3 and the square root of 3 will end up being 3, remember that? And then the numerator will be 6 square root of 3. Now, it might look like the final answer, but remember we always like to simplify values in maths. So this simplifies to 2 square root of 3. Always remember to simplify, even when they ask to just rationalize and they never really ask you to simplify, you always need to simplify. So that's it. That's all the rationalization, rationalizing the denominator asks you to do. Just take whatever you have at the bottom, anything you have at the bottom, just multiply the value there. Let's say you had 10 over 2 square root of 2. Well, in this case, I'm going to take exactly that 2 square root of 2 and I'm going to multiply top and bottom by that. And so the numerator is going to be 20 square root of 2 and the denominator will be, well, 2 times 2 will be 4, and then the square root of 2 times the square root of 2 will be times the 2. If you still ended up with a surd, it means you did something wrong. Either you multiplied by the wrong surd or you actually missed out on one of the properties. So in this case, I can write this as square root 20 square root of 2 over 8. I could have simplified it a step ahead, but I just need to show you this. You might end up with this number. Remember, you should simplify it, and it should simplify to 5 square root of 2 over 2. So this is the final answer. I can't simplify any further. One other thing, I know I said that you rationalize by taking the same denominator. Well, sometimes you don't have a single term. You actually have this. If you have an expression, so it's not a multiplication, if something's being added or subtracted, in this case, you take what we call the conjugate. So the conjugate is when you take the exact same expression, but instead of this sign, you just take the opposite sign. So if it's a plus, you take a minus. If it's a minus, you take a plus. So in this case, you're going to do 3 minus square root of 2 over 3 minus square root of 2. And the numerator will be 1 multiplied by that, which is just 3 minus square root of 2. The denominator will be, if you have seen the previous video, you would have spotted that I actually don't need to go through the whole expansion, as these two are just the difference of 2 squares. I can use the rule for the difference of 2 squares. So if you have this. I have the same terms inside, one with a plus, one with a minus, so I just need to square the first one minus square the second one. So this will be 9 minus 2, which is 3 minus square root of 2 over 7. Again, if you're unsure about this, I'm just going to quickly explain. The 9 comes from doing 3 squared, and the 2 comes from the square root of 2 squared. Do watch the previous video at the end of the previous video to see, because I actually use the same exact values. So you end up with 3 minus square root of 2 over 7. This can't be simplified any further, so that's as furthest as we, this is as furthest as we go. The type of question you'll be asked with this, or the way the question will be phrased, is by saying, it's going to ask you to express the denominator using an integer. And this is just a longer way of saying, well, rationalize the denominator. And so this is what we did. We just turned it into an integer. Remember that integers are rational numbers. So that's it. So remember that it might be asking you to do it in such a way, or it might say rationalize the denominator. It might also say write something in simplest form. So rationalizing is not just because you want to write it in integer. Sometimes it's the simplest way of writing an expression. So let's say I have 1 minus 2 square root of 3 over 1 plus square root of 3. Well, in this case, it seems like it's the simplest form. You can simplify it further, but if the denominator is not in a rational form, it means you can actually do something about it. So if you seem like you're stuck, just remember all of the properties we've done before. Can you use property 1? No. So there's no squaring a square root. You can't really collect for like terms. You can't do the whole multiplication rule. You can't use the division rule. And you can't expand the bracket. You can't simplify the numerator and denominator. So try to rationalize it now. So do pause the video as we go along. Try to attempt the steps, and then you can unpause and resume the video and see where we are. So to rationalize this, I'm going to have to multiply it by the conjugate, which is 1 minus square root of 3 over 1 minus square root of 3. So I'm just going to put all of this under one bracket, under one fraction, sorry. Over 1 minus square root of 3, and then 1 plus square root of 3, 1 minus square root of 3. Again, do write your arrows when you want to expand the brackets, especially with this example, as you have quite a lot of surds in there. And the numerator is just using the rule for the difference of two squares. So for the denominator, you'll end up with squaring the first one and then minus squaring the second one, which is 1 minus 3, which is just simply negative 2. And as for the numerator, so multiplying each term will give you 1, and then minus square root of 3, minus 2 square root of 3, and then you have your positive 2, so that's the value outside, and then you have your, so I'm just going to do on the side, so it's a negative 2 square root of 3 times a negative square root of 3, so you have your negative 2, your positive 2, and then you have a square root of 3 times a square root of 3. The positive came from the fact that you have two negatives here, so you end up with a positive. And then square root of 3 and a square root of 3 is just simply 3. So you end up with a 6 on as the last term. And then we simplify this using all the properties we've used before. So you have collecting the like terms, so 1 plus 6, that's a 7, and then negative square root of 3 minus 2 square root of 3. So you end up with negative 3 square root of 3. Now you can leave it as it is, but if you don't like a negative number in the denominator, as soon as you remove a negative number from the denominator, you actually switch all the signs. So the 7 ends up being a negative 7, the negative 3 square root of 3 becomes a positive 3 square root of 3, and it's over a positive 2. It's still the same thing, doesn't matter which one you keep it as, just it's good practice to keep the denominator as a positive number. You can stop the video here. This is the end of the Surds videos. I will take a few minutes just to explain the last parts that I just did, which is not essential. You can still use the facts that I said, which is if you change the sign, you just change all the other signs as well. So just to explain why that is true, if I have 7 minus 3 square root of 3 over negative 2, you can use it, you can explain this in many different ways, but I'm going to explain it by, well, I can multiply by a negative 1 and a negative 1, and it won't really change the value of the fraction. And so a negative 2 times a negative 1, that's a positive 2. And then if this whole thing is on a bracket, remember, if I multiply negative 1 by every term, I end up with negative 7 and a positive 3 square root of 3. And I'll just swap them around just for convenience. And that is why it's true. But you don't really need to show the step as long as you understand that you need to change all of the signs, and they change because of this fact.